Welcome back, students. Now let's move into the second section of this notebook, implicit curves. Here are a couple of examples. An ellipse given by this implicit relation. We saw this example before actually in the previous videos. And then the portfolio is another example. It's given by this implicit relation between x and y. Of course, there are a bunch of others, but the key thing is we are looking for the tangent lines. And we're going to follow this kind of step-by-step process. Basically, we are looking for the slope point equation of the line. The point x0, y0 will be given typically. And how about the slope m? That's what you have to find out through implicit differentiation. Take the derivative implicitly and find out y prime, and that y prime value evaluated at appropriate x0 and y0 value is going to be your slope. And then once you get the slope and the points, then you have slope point equation. Now in some case your slope is undefined. In that case you'll have to have a vertical line. We'll see. Okay, let's take a little bit closer look at these through some example problems. Let's begin with the simplest one here. X squared plus 3y squared plus 2xy plus x is equal to 1. And this curve will turn out to be, I don't know, let's see. And let's see, we are looking for this. That's equal to 1. And then x is, well, the point is negative 2 comma 1, so let's go a little bit further and then a little bit like this. Y and then let's see. Don't pay too much attention to mathematical code here. Okay, here's the curve. Looks like we're going to get an ellipse, which is a little bit tilted. And the negative 2 comma 1 is, let's see, negative 2 comma 1 is around here. So you're going to get a slope of tangent line here touching kind of like this. So it looks like it's going to be positive just by looking at the graph. Anyway, let's find out the precise solution. Don't kill us yet. So how do you do that? We are looking for y equals to slope m, which you have to find out, x minus x0 plus y0. This is slope point equation. What is x0? It's given as negative 2, so you have to have this kind of answer. Y of 0 is 1. So this is the typical solution you're looking for if the slope m is well defined. How do you find it? Through implicit differentiation and by plugging the numbers. So this is where we headed. Keep that in your mind, and then let's go ahead and do this. Let's see, implicit differentiation, 2x plus what's the derivative of the second? 6y, but don't forget y prime. And then 2xy, that's going to be the product rule. 2y plus 2xy prime. And then finally, the derivative of x is 1. And derivative of 1 constant, that's 0. Please recognize that I used chain rule here to get this y prime here. And then product rule here to get this derivative of first function times second function plus first function times the derivative of the second function. And finally, the derivative of this y is y prime. We have all that. And what do we do here? We're looking for the slope, right? Okay. Now this y prime is my slope. So let's replace that with m. How about x and y value? Those are -1 and 1 respectively. So x is negative 2, x is negative 2, and then y is positive 1. And this is, so that is my equation, and then it's a linear equation of m. I don't think that's too difficult to solve. Let's see, 6m minus 4m. If you put together these two m's, and how about these others? Negative 4 plus 2 plus 1 is equal to 0. So looks like you're gonna get 2m is equal to, flipping everything to the other side, let's see, 2m minus 1 is equal to 0, m is equal to 1/2. So the solution you're looking for is this: y equals to 1/2 x plus 2 plus 1 by the slope point equation. Let's go back here. Implicit differentiation. Plug in the numbers. X, y are negative 2 and 1 respectively, and y prime is a slope m. So for m, once you get it, then put everything into the slope point equation. Feel okay? Alright, let's go to the solution here. So slope is 1/2, and this is a graph, and well, the solution, the same thing we did before, right? Okay, let's move on to the next problem. This time I'm gonna save a little bit of time, so I may just go directly to the answer key. Let's see, we have to take the derivative of x squared and then take care of this product rule, and then derivative of y cubed, which is 3y squared times y prime, and plug in x equals to negative 1, y equals to 1. Alright, here we go. Implicit differentiation. Well, let's see here. I'm a little bit dissatisfied with this expression. Too many negatives. I'd rather consider this one as negative x times y. So basically we have this 2x, and then what is the derivative of negative x? That's minus 1 y plus, and then what is the derivative, what is the second function? That's minus x, isn't it? So minus x, what is plus or minus x? That's just minus x. And then the derivative of y, so that's y prime, and then 3y squared y prime is equal to 0, and that would have been a little bit better rather than having extra parentheses and then distributing negative 1 away. You see, if you consider this one as plus of negative x times y, if you write it like that, if you regard it like that, then you get this kind of computation right away. Anyway, it's just algebra. We get y prime equals to negative 3/2. That is my slope. So we have slope point equation like this. How about the visualization? Indeed, we get what we want. Now we have plenty of time, so let's do several more problems. How about this one? We have derivative of x squared to take care of. That's good. And then what do we have? We have a product rule, but not just product rule, but we have to deal with the exponential function. Not too bad. And the derivative of 2y, that's going to be just 2y prime. Okay, the only non-trivial part here is to deal with this product rule here. And then plug in x equals to 1 and y equals to 2. Ready? Okay, here we go. And this part is the product rule part. Again, here I use parentheses and then just these instead of just getting this negative of e to the x minus first power as one function. Either way, it'll work out. So the derivative of first function, exponential, stay the same, and second function. First function times the derivative of second function, and there we have this y prime. And then plug in numbers. X is 1, y is 2, and then y prime is m. And x minus 1 is 0, so we have e to the 0 power, which becomes 1. So we get something simple, and in the end we get m equals negative 1. Consequently, slope point equation yields this. How about the visualization? Good. All right. Another problem before the end of this video. Let's go with this problem. Now, the left-hand side is a little bit more challenging. You're taking the derivative, and you'll have to use the chain rule. 2 comes out, and then inside stays the same, and then multiply the derivative of the inside. Okay, here we go. Two comes out, inside stays the same, good. And we multiply the derivative of the inside. X squared becomes 2x, fine. Negative y squared, negative 2y, y prime, good. 2y becomes 2y prime. The right hand side, 8xy, that's going to be a product rule. So we have that. And plug in appropriate number. X equals to 0, y is 2, and y prime is m. And let's solve for m. There's a bit of a surprise though. Left hand side, what do we get? 0 minus 4 plus 4, this whole thing is 0. So left hand side is 0 times something, left hand side is entirely 0. And then right hand side, what do we get? X equals to 0, so 8 times 0 times slope, so that's also 0. What do you get? This is 0, and that's 0, so we get 0 equals 8 times 2, 0 equals to 16. Of course, that doesn't make any sense. So if you see something like this, then what do? Do you panic and try to look for some mistake? Maybe, but in case of implicit differentiation, this may be just a norm. As a matter of fact, this may be telling you that there's no such thing as m. Indeed, if the slope is undefined, you're going to get a vertical line, and x equals x0, x equals to 0 may be the tangent line you're looking for. Is it really? Well, here is mathematical verification, and here we go. In order to see this property better, I disabled the coordinate axis and then put the frame instead. So y-axis, x equals to 0, this is indeed the tangent line. The point 0, 2 is right here. Sometimes this kind of thing happens. When the slope is undefined, or you get something ridiculous like this, 0 is equal to 16, you look for the vertical tangent line. Oh, still a little bit more time. Okay, we'll have time to talk about this one. Okay, that's good. Let's do the same thing. Let's take the derivative of the left hand side. Derivative of x squared, 2x, that's piece of cake. Derivative of 8y squared, 16y, but y prime. The key is to handle the right hand side. What do? The chain rule, of course. 2 comes out, inside remains exactly the same, and subtract 1 from the power, and multiply the derivative of the inside, which is like this. The chain rule. This is the derivative of the inside. Once you have that implicit differentiation, plug in the values. X equals to 1, y equals to 1, and y prime is m, and just solve it. a bit of a simplification step by step, and in the end you're going to get m equals -1/2. So you get the slope point equation here. That's going to be your equation of the tangent line. How about the visualization? We have something like this, and then y equals -1/2, parenthesis open, x minus 1 plus 1 yields indeed the tangent line. Oh, by the way, we have two different pieces of implicit curve, this piece and that piece. Well, we may have 2 pieces, 3 pieces, 5 pieces, or infinitely many pieces. Those kind of things are rather common in implicit curves. I have 2 more problems here, but I'm going to leave those to students, and we'll say we are done with implicit curves.